In the last video, when we talked about homogeneous systems, we solved this linear system. But now I'm interested in this system on the right, which is essentially the related non-homogeneous system. The only thing that's different between these two is the one on the left is homogeneous and the one on the right isn't, but all of the coefficients are the same. So let's solve this system on the right and see what we get. We start by putting it in an augmented matrix. And now we can start solving the system. We want to start by getting a 1 in the first row, first column. So we're going to multiply the first row by 1/2. The second and third rows won't change. And the first row becomes 1 minus 3, 2, 1. We now need to get zeros below it. We already have a 0 in the third row, so we just need to turn the second row into a 0. So we'll do negative row 1 plus row 2. My first and third rows won't change. I then have negative 1 plus 1 is 0. Negative 3 minus 2 is 1. Negative 2 minus 6 is negative 8. And negative 1 plus 3 is 2. I already have my 1 in the second row, second column. So I just need to get zeros both above and below. To get a 0 above this one, I'm going to do 3 row 2 plus row 1. My second row will not change. I then have 3 times 0 is 0, plus 1 is 1. 3 times 1 is 3, minus 3 is 0. 3 times negative 8 is negative 24, plus 2 is minus 22. And 3 times 2 is 6, plus 1 is 7. For the third row, I currently have a 1 where I want a 0. So I'm going to do negative row 2 plus row 3. 0 plus 0 is 0. Negative 1 plus 1 is 0. Negative 8 is 8, minus 8 is 0. And then negative 2 plus 2 is 0. Now that we've done that, we have solved this system of equations, and we can start by writing down our equations that this matrix gives us to figure out the solution set. Writing out the equations gives us x1 minus 22x3 is equal to 7, and x2 minus 8x3 is equal to 2. So now we need to solve for our basic variables, solve for x1 and x2. So now I have my solution. x1 equal to 22x3 plus 7, and x2 is equal to 8x3 plus 2, and then x3 is any value. So I really wanted to see if these two were related at all. And you'll notice that if you recall from the last video, when we solved the homogeneous system, our solution was that x1 is equal to 22x3, and x2 is equal to 8x3. x3 is equal to any value. So these are very, very much related. The non-homogeneous, the related non-homogeneous system that we just solved have these extra terms added to the solution, but the coefficients are still the same. Let's suppose a linear system is consistent. I want to kind of generalize this idea on the relationship between a homogeneous and a related non-homogeneous system. So we're going to suppose that we know the linear system, the non-homogeneous one, is consistent. Then the solution of this system is going to be of the form h plus p. So we'll go into exactly what h and p are. H is the solution of the homogeneous system, and p is the particular solution to the linear system. So let's go back up to our last example and see if we can understand this a little bit better. So here's our last example. We said the solution should be of the form h plus p, where h is the solution of the homogeneous system and p is a particular solution. We can definitely tell that these are of the form h plus something, where h is the solution to the homogeneous system. For the homogeneous system, I had 22x3 and 8x3. So we definitely have those plus something else. In addition, the point 720 is a solution to the non-homogeneous system. And so that's why we have the +7 and +2. That's what we mean by the particular solution. So now let's see if we can give a geometric interpretation to what's going on here. We're going to suppose a system has one free variable, and there are expansions of this if you have more than one free variable, but for now, for our geometric interpretation, we're just going to stick to one variable so it's a little bit easier for us to visualize. In this case, the solution to the homogeneous system is a line through the origin. We know we have a free variable, so it can't be just the trivial solution. We know we have non-trivial solutions, and it is represented as a line that passes through the origin. Then the non-homogeneous system will be represented by a parallel line. And in particular, essentially, I'm going to take the homogeneous system and I'm going to shift it. I'm going to translate that line by the particular solution, P. Let's suppose I have a solution to a homogeneous system. And as I said before, this can be represented by a line passing through the origin. So we'll say this is my line here. And let's say in this case, P is 1, 2, 0. So my particular solution is 1, 2, 0. So x1 is equal to the homogeneous solution plus 1. x2 is the homogeneous solution plus 2. And x3 is my free variable. Then essentially what I'm going to do is I'm going to take every point and move it over 1 and up 2. So now I have this point. I'll move this point over 1 and up 2, and I have this point. And we can keep going, but essentially we will get a parallel line. Not a perfect graph, but we get the idea. We have a parallel line where I essentially took points and shifted them over 1 and up 2. So I've shifted this parallel line by my particular solution.